Okay, so now we're picking up where we left off with our starter program from the previous video where we got it to show us a stimulus. So we got it to display, we started off with a red circle, I think we changed it to green. I don't remember, did we do that? Anyway, right now it's showing a green circle. And so now what we're going to do is take that sort of starting place and make the structure of starter a little bit more convenient for future complexity. So writing actual experiments, behavioral experiments, it's usually going to be more convenient rather than having stimuli displayed and collecting responses and so on in the main function. It's usually better to have that in a separate function. So that's what we're going to do now. We're going to structure our program so that it has a separate function. We're going to call that function trial for now, because in a lot of psychology experiments or behavioral experiments, we call each instance where the participant could respond, we call that a trial in an experiment. So we're going to call our function trial, and we're going to add that and make that functional and make it basically do exactly the same thing that the program is doing now, but with a slightly different program structure that is then going to be more convenient when we start going to multiple trials and randomization of trial order, that sort of thing. All right. So the first thing we're going to do in order to make that a reality is we're going to write a new trial. We're going to define a new trial down here. We're going to declare a new trial. It's going to be an int, and we're going to call it trial. And for now, we're just going to leave it like that. I'm going to do my open and close brackets, hit enter to give it some space here where I'm going to put stuff eventually. And now we have the trial. But remember what I told you about the compiler. The compiler reads when it's writing this program for us, when it's basically translating our code into machine language for the computer. It does everything linearly from the upper left to right, from top to bottom, just like you read in many languages, not all languages, but in many languages, just like reading is. It starts from top left down to the bottom right, and it does everything linearly. So if it comes across a call to a function that it hasn't seen yet, it's not going to know what to do, and it's going to freak out. So we can't just put the new function down here below main. We could write the whole function above main. There's reasons, I get into this in the book, reasons why that's less convenient often. So instead, what we're going to do is put up here a function prototype, and basically the function prototype is just this definition right here. So I'm going to copy that. I'm going to right click and copy. Yeah, there's a copy. Just so you can see what I'm doing. Normally I would just use fast key, Control C, but I'll right click so that you can see it on the video, and paste. Now, remember our rule about semicolons. Put a semicolon after every line except for the ones that don't need it. Well, this line needs it. The function prototype needs it. This line does not need it. The function definition does not need it. Okay, so now we've got our function prototype in there. And now, before we go any further, one more thing we're going to do before we do that. So we've made this function into an int, an integer. It's going to return an integer. And because we've made it an int, we need to return something. So we are going to return, for now, 0. Eventually, we'll probably return the response that we get from the participant in this trial. But for now, we're just going to return 0. And now I'm going to go ahead and make sure that it still works. Make sure that I haven't put any bugs into the program. You know, I might have forgotten a semicolon here. I might have forgotten one up here. I might have misspelled, the spelling of this versus this one. You never know what mistakes you're going to make when you're doing this. So as I say in the book, compile early and often. We're just going to go ahead and run it with the local Windows debugger. Make sure this thing still runs. And indeed it does. It still shows us our one little green circle. I have it going on for 10 seconds so that I have time to reach over to my second screen and drag it over to the screen I'm actually recording. But if you're doing this at home, you should just have 1 second in there, just to have it go on for 1 second, just long enough for you to see that it actually works. All right. Now, what we're going to do is move everything. We're now going to move the display of that green circle from main into trial, so that everything that has to do with the display of the green circle goes from main into the trial function. All right, so one of the things that we need to display that circle is the Allegro color right here. So I'm just gonna start using fast keys. I'll just tell you what I'm doing. I'm gonna cut that. That's Control X, cut, and paste that down here. Control V to paste. I'll do a little enter there to give myself some space. Also, all of these variables right here have to do with that circle, right? The screen height, screen width, target size, all of that has to do with displaying that circle. So I'm going to Control X again, paste that down here in the trial function. Let's see, what else? Circle color, the definition of that, and how we get screen height, screen width, and the target size. Actually, all of that goes away. So cut that out of main, stick it down here in trial, and all right, finally, draw the circle, flip the display, and the rest. I'm going to cut all that, bring it back here, and put it in our trial function. Okay, now there's one more thing we have to do. Well, there's a couple more things we have to do, actually. One thing is, right now, in trial, there is no display, but I am telling this thing to draw a circle and then flip the display. So I actually need to pass the display that I created in main to trial. Now I could instead create a new display in trial, but that would mean that every time I called trial from the main function, I would have to create a new display, and every time I exited trial, I would have to destroy that display or else risk a memory leak. And remember, I talk in the book about memory leaks and how you can very quickly gum up your computer. And especially in something like this, where we're going to be calling this trial over and over again, it wouldn't take very long for your computer to slow down and grind to a halt if you have a memory leak. So instead, we're just going to create a single display, and then we're going to pass that display in our function call to our trial function. All right, but because of that, I need to tell it. I have a Allegro display coming in, and its name is display. Now, some programmers will tell you don't name it the same thing in multiple functions because that can cause problems. For me, it causes more problems of understanding when I name them different things, and I've never actually had a problem calling it the same thing, so I'm not 100% sure that that's accurate. It probably is. You'll probably run across problems, and you'll probably curse me in your later years as a programmer, but I'm just going to call it display in the trial function, just as I call it display here in the main function, and I've done that for years and never had a problem. Okay, so we passed that display, and now I have to add this same call in the function prototype. We can't forget the function prototype. So up here in my function prototype, while we're at it, I should just probably real quickly give you some good habits. You should comment like crazy, especially early on in your coding career, but even later on. Comment what everything is doing. At the very least, comment the different sections of your program. And so I'm going to put a comment in here, function prototypes. And that's, this is where my function prototypes live, is up here. And I can make this a little bit easier to spot if I'm scrolling through code by doing something like that. So I've just created kind of a bracket here telling me there's my function prototypes. Okay, fantastic. And let's see, we can get rid of some of the spaces we have here now in the main function. And one of the things you'll notice is, now look how short main is, right? Main is no longer this terribly long function with lots and lots of lines. It's now fairly short. Now, eventually our main function is going to be pretty long, but not as long as it would be if we weren't doing things with separate functions. So you can see it's much easier to read through. It's much easier to figure out what it is main is doing this way. So we're going to keep it like that. Okay, and I think we are ready to go. I think I've not forgotten anything. Let me just double check my cheat sheet over here. Oh, we have, we've forgotten a very important thing. Oh my goodness. If we try to run this now, it'll run. I don't think it'll complain. I don't think the compiler will complain about anything. But we will not see our green circles because I forgot the call to the trial function. We have to actually call that function. So I'm going to do that right here below. I have this commented show native message box thing that I've kept in here. So this is where I'm going to call the function trial, and then I have to pass to trial the display, and this is a line that requires a semicolon at the end. All right, so let's run this. I think this is everything. Let's try it. Aha! Look at that. Beautiful. Okay, so now we have a program structure that is much more similar to what we'll actually be using to write experiments where we're showing, like, 100 trials, 200 trials, 5,000 trials to a subject, and collecting responses from them. We'll in the future, I'll just give you a little preview. In the future, we'll have other functions down here to do things like evaluate the response and give feedback and make adjustments to parameters, whatever it is that we need to do. But that's enough for now. I'm going to call it and, well, get back to work.